Okay, so this is a pretty quick lesson here. It just covers a couple things we want to go over. So there are a few other sampling methods other than, say, a simple random sampling, which is, great, but not always possible to do. We don't always have a list of everybody. Could be some other reasons. So one way is to break folks into strata. Stratas are like a group. So strata, think of stratified as a group of individuals who share some characteristics. So but that is something important in the study, that you think they have similar characteristics. And so you want to pick people choosing, so inside of each strata or each group that have some similar qualities, you want to do a simple random sample inside of each group. So it's kind of like breaking into groups and then doing simple random sampling within each group. So it works best when you have a homogeneous group. So you've grouped, like you could maybe stratify by gender, right? So males and females, you're going to separate them first, and then within the males and within the females, you're going to do some kind of simple random sampling. So you're breaking them into homogeneous groups, groups that have similarities to them, that you're trying to see, maybe men react differently than women for this, whatever they're studying. Or could be by grade level, right? So you're putting people, 9th graders together, 10th graders together, 11th graders together, 12th graders together by homogeneous group. They all share the same grade. And then within each grade, you are doing a simple random sample. So you're still doing a simple random sample, but you're grouping them first. So remember, with simple random sample, you can't do any kind of grouping first. You've got to just have a list of everybody. Everybody has an equal chance of being selected. Here, it's a little different, right? If we had 60% guys and 40% girls, and we did a stratified by gender, then you would probably select 60% of the sample would be guys and 40% of the sample would be girls, because you would select proportional amounts typically when you do that. And so they give pretty precise responses, and you can kind of tell then if males or females or whatever you stratify by has an effect. Another sampling method is called clusters. So clusters, people who are grouped together, but not because they share a similar feature. Actually, in this case, you don't want them to be homogeneous. You want them to be representative, is a good word there, including, but they do tend to be located near each other. And sometimes this can be okay if you can get a good representative cluster. So with that, let me just make sure you get that. So cluster, let me give some examples of clusters. So you could, let's say, clusters could be like zip codes. Okay, so if you're in, let's say Memphis, there might be, we all have the same area code, but we have different zip codes. We live in different areas. Some are Cordova, some are Germantown, etc. So you could get a cluster of folks, maybe just one of the zip codes, and do within there. So select by random choose the clusters, including each member of the selected cluster in the sample. So if we did that by zip code, wow, that would be a big job. Then you have to kind of do a census within the cluster. So you ask everybody in that zip code or whatever you're doing, what the question that you're studying. You investigate further with each person in the clusters that have been selected, hopefully randomly. And so it's used for practical reasons for sure. It's hard to get a good cluster sampling. And if you get a good cluster that's representative of, the population you're studying, then that's pretty nice, but it doesn't happen very, very often. We could use systematic. So systematic is actually another kind of easier way. Still has some random chance to it. But if you select a sample by selecting the first K individuals and every Kth individual after that. So for example, like if we had an assembly in the gym for 9th through 12th graders for high school students. So I might kind of every 10th person gets asked a survey question. So every 10th person that walks into the gym. And so that would probably be okay, right? Because even though some 9th graders may group together, some 10th graders may group together in smaller groups, not everybody's, entering at the same time. It's going to be somewhat of a random sampling of folks. When you just stick to whatever the 10th person is, they get asked the question, or they get, investigated further into what you're studying. So, and so you don't know how many folks are coming by, but you just kind of, every 10th person or every 5th person, or whatever you decide on. If somehow that pattern you chose kind of coincides with some quality they have, I don't know how that could happen, but if it was married couple, I don't know. There could be a way that could happen. I don't see that happen too often, but there could be a question that can come into play. You want it to be random, right? So we want it to be some kind of like just kind of random, the 10th person, the whatever person you're studying there. And that's a pretty easy method to use, not terrible, to get a good random sample that hopefully might be representative of the population. Okay, so let's try a couple of problems, just make sure you're kind of getting the ideas, especially those first two, which are the tougher two of the two there. So school librarian wants to know the average number of pages in the books that are in the library. The library has 20,000 books, wow, arranged by type, fiction, biography, etc., in shelves that hold about 50 books each. So every shelf holds 50 books. You want to select a random sample of 500 books. Okay, so how do you do it? Well, how would you do that? By stratified. And justify your choice of strata. Why would you choose that to stratify by? Well, so you want to put homogeneous things together here. So I would think, you might want to stratify by the type of book, like fiction, biography, history, etc. It's very possible, I don't know if this is true, but maybe history books are a little bit longer and fiction books are a little shorter, or vice versa. But if we're trying to find the length of the books, it's very possible that biographies have more of a shorter length or longer length than some other genres. And so if you kind of group them first and then take a simple random sample in each group according to how big their size is. So in other words, if there were 5,000 fiction books out of 20,000 books, that's a fourth of them, right? So you would want to take a sample of maybe a fourth of 500. So 500 half is 250. So you'd want to sample 125, which is a fourth of 500, because you have 500 total in the sample. So you could do it something like that. Here's what they said. Stratify by type of books, because different books may be shorter or longer. It will provide a more precise estimate. That's what we think that stratifying usually does. It's a very good method many times if you can find something that has some similarities. You would take an appropriately sized thing. So they said if, for example, there were 1,000 biographies, that's what, 5% of 500 is, that's 5% of 20,000, 1,000 is. So 5% of 500 is 25. So you would sample 25 of the biographies, right, randomly. So you have all the biographies together and you randomly choose 25 of the 1,000. Again, you just kind of do it in a proportional manner and set that up. Could we do a cluster? Well, in this case, I think we could. So we have 50 shelves, 50 books in each shelf, and there are whatever 20,000 divided by 50 is how many shelves you have. So if we want 500 books, I think we would want, 10 shelves of books? We're going to randomly choose 10 shelves of books. And so why would you want to do that? Well, we're hoping that maybe on each shelf, even though I would think the biographies might be together in many cases, or the fiction may be kind of together in the same shelf, by randomly choosing 10 different shelves, you might get some of each, right, kind of thing. So hopefully that'll work out. I don't know if it'll work out. Clusters are a little harder to make it work. This is what they said. The groups that are located so near each other. So we're just, again, clusters, they're located near each other. It's kind of easy to do. We can use each shelf of 50 books as a randomly select 10 shelves. So we're randomly selecting 10 of them to get the 500 books. Number the shelves from 1 to 400. Choose an SRS of 10, remember, simple random sample of 10 shelves, then use all the books on those 10 shelves as a sample. So again, within the cluster then, once you've chosen those 10 clusters of shelves, those 10 shelves essentially, then within that cluster of 10 shelves, you're going to do a census inside of there. So you're going to look at every single book that was selected there to do that. Okay, that's your lesson for today.